Section 6.4, number 21. We need to solve this equation using identities. So the first thing I want to do is get everything into the same trig function. So I will take this guy and use the Pythagorean theorem to rewrite sine squared in terms of cosine squared. And I'm okay with the x over 2 in there because we can always solve for x minus 2 and then multiply to 2 to get to x. So we have 2 times all that minus, so I should probably keep that part in black since I'm not changing any of that. So 2 times that minus 3 cosine x over 2 equals 0. Okay, so now I have something kind of ugly. So I'm going to use a little factoring, distributing. So I'm going to distribute that 2 into here. So I get 2 minus 2 cosine squared of x over 2. Don't worry about that x over 2 for right now. Minus 3 of cosine of x over 2. And this is starting to look a lot like a quadratic. And to make that a little more obvious, I'll go ahead and use substitution and let u equal the cosine of x. Actually, let's do cosine of x over 2 since we're not worrying about that part just yet. So I'm going to substitute, so I'll have 2 minus 2, and then instead of cosine squared, I'll have u squared. So that's u squared minus 3, and instead of cosine, I'll have u. U equals 0. So now if I just reorder this, because it's a quadratic, so I want to go from descending order of the power. So negative 2u squared, just changing the order to 3u plus 2 equals 0. And now to factor this, I don't have a leading coefficient of 1, so that means I need to use grouping. So I have, I need to look at negative 2 times 2 to get a negative 4, and a sum of negative 3. But since it's a product of negative 4, that really means I want a difference, because one number is going to be positive, one number is going to be negative. So what's going to have a difference of 3? And those factors are 4 and 1. And I'll have a negative 4. So when I add those together, I get negative 3. When I multiply them together, I get negative 4. So I'm going to replace this negative 3u with a positive 1 and a negative 4. Again, not changing the values. So that's plus u minus 4u. So that if I add those together, I'll get that negative 3u, but I'm just separating them out. I'm actually going to do it in the other order because that makes the grouping a little easier when my second number is positive. So I'll do a minus 4u plus 1. Plus 1u. So when I add them together, I get negative 3u. And then the rest I'm just going to copy down. And here is when I do the grouping. So I'm going to group these two terms, and I'll group these two terms. So in my green group, my GCF is a negative 2u. So I'm left with u minus 2. And on the purple group, my GCF is actually just 1. So I can write a 1 out in front, u plus 2 equals 0. And then that u plus 2 is identical, which is what I want. And that means I can pull it out in front, treat it, that's a plus sign, then on a minus. Oh, okay, so I made a little mistake on the green group. I took out a negative 2u, but I did not take the negative out of the second term. So that should have been a u plus 2. All right, now I have matching terms. Now I can bring them out in front. So I have a factor of u plus 2 And when I factor that out, I am left with negative 2u plus 1, all equal to 0. This is a zero product property because I have multiplication. Two numbers multiplied together, one of them must be 0. So I have either u plus 2 equals 0 or negative 2u plus 1 equals 0. On the case on the left, I end up getting u equals negative 2. And on the case on the right, I get negative 2u equals negative 1, which gives me u equals 1/2. Now I'm done with the substitution. That's as far as I can go with u. I need to go back and figure out try to remember what is that u and plug that in. So that was cosine, right? Cosine of x over 2. So I have cosine, whoops, wrong color. Cosine of x over 2, that was u, equals negative 2. And I have, on the right, I have cosine of x over 2 equals 1/2. Okay, let's look at one equation at a time. Let's look at this blue one. I have cosine of something equals negative 2. And I know that the range of cosine is only negative 1 to 1. So that is not possible, so this is undefined. So we are done with that side. Now it remains we can have solutions on the right-hand side in the green equation, because cosine of something can definitely be 1/2, and that's on our unit circle. So I can take cosine inverse of both sides, and I'm left on the left side with cosine and cosine inverse cancel each other. I'm left with x over 2. And on the right, I think, okay, so when is cosine equal to 1/2? And looking at my unit circle, I find that can happen at pi over 3. And the other time, it can equal 1/2 would be at 5 pi over 3. Okay, and then solving for x, I need to multiply both sides by 2. All right, x by itself, I get x equals 2 pi over 3. And on this side, I multiply both sides by 2. I get x on the left and 10 pi over 3 on the right. So that gives me two possible solutions for x. Not quite. Actually, come to think of it, there's something wrong with one of these, because then I remember from my directions, I'm looking for solutions in 0 to 2 pi. But since I was my x was actually x divided by 2, once I solved for x and multiplied by 2, this guy got too big. That is bigger than 2 pi over 2 pi. So he's not in our range of where we want solutions, our domain. So we are left with just one possible solution for x.